This is number 38 in section 4.5 of our book. Got to get familiar again with three things here. The first thing we want to do is identify what conic section we have. Second thing we got to do is put it into standard form. And the last thing we have to do is be able to graph it correctly. So let's do all three of these for this problem. The first thing we want to do is to identify what conic section we have. Now, if you didn't have the book, you would know that. If you had the book, you would know what it is. But let's go ahead and just try to look at this problem, and we can determine what conic section it is. Right here, we have an x squared and a y squared term. Once we have an x squared and a y squared term, we know it's not a parabola. Again, parabola only has an x without a square, or maybe it has a y without a square. But because it has an x squared and a y squared, we know it is not a parabola. Okay, what now we need to do is we need to look at the leading coefficients here. So we're going to look at this 9. We're going to look at that 4. They're both the same sign. So they're both positive 9 and positive 4. But they're different numbers. If they're the same sign but different numbers, we know it is an ellipse. So again, same sign, different numbers. That is an ellipse. Okay, for the other two, just to make sure, let's just cover that right now. So if they're the same sign and the same number, then it's a circle. And if they're opposite signs, then we know it is hyperbola. So again, we're looking at those leading coefficients. That's how we have to get comfortable with that. You're looking at those leading coefficients of the x squared and the y squared terms. Same sign, different numbers, it's an ellipse. Same sign, same number, it's a circle, so like this would be 9 and 9. Opposite signs, it would be hyperbola, like -9 and +4. So we know that these are the same sign, different numbers. We know this is an ellipse. So when we're trying to do an ellipse now, we're going to try to, looks like we're going to try to complete the square. We're going to try to keep the x squared and the y squared on the same side and then move the constant to the other side. So let's group, and we also want to group these x terms together here. So again, I just rewrote the equation from up top, but all I did is I grouped the x terms together, the y terms together, and I moved the constant over. So now what we're going to do is, let's factor out the leading coefficients. Again, what we need is we need a leading coefficient of 1 right here. That's what our goal is. Okay, now we're going to try to complete the square. So again, what we're going to do is we're going to divide this by 2. -4 divided by 2 is -2, and then square it. So that's +4. If I'm adding 4 to this side, I'm actually going to add 4 times 9. So I'm going to be adding 36 to this side. Okay, same thing right here. We got 2 divided by 2 is 1. 1 squared is 1. But we're not going to just be adding 1. We're adding 1. Oh, let's get that. Sorry about that, you guys. There we go. We have 1 times 4, so it's +4. Okay, now let's go ahead and complete the square on all this stuff. So again, we're just dividing this number by 2. -4 divided by 2 is -2. I'm going to have 9x minus 2 squared plus 4. Okay, 2 divided by 2 is 1. Y plus 1 squared equals -31 plus 36 plus 4, which is 9. Okay, to get into the standard equation of an ellipse, again, we need the right side of the equation to equal 1. And that's what we must have. We need the right side of the equation to equal 1. So you can see it's starting to look a lot like that the standard form there. So if we look up here, you can see we're getting that x minus term there. We're getting that y minus or y plus term there squared. Now we got to get that side to equal 1. Again, the way you do that is you're going to divide everything by this number. So divide it by 9. Okay, so this side we know it's going to equal 1. Okay, the 9 divided by 9 here will cancel out. But we want to write it in standard form, so let's write it as x minus 2 squared over 1. So we're going to keep the fraction. Okay, this one's a little trickier now. You have 4 over 9. But what we want to do is we want to have the top just be by itself. Y plus 1 squared. So what we're going to do is we're going to move this 4 down. This is the same thing as saying 4 divided by 9. What's the reciprocal of 4 divided by 9? 9 divided by 4. So it would be 1 over 9 divided by 4. Again, let's think about that again here. I have 4 divided by 9. I'm going to take the reciprocal of that. 4 over 9 is 9 over 4. So 4 over 9 equals 1 divided by 9 over 4. Okay, right here, now we have it into the standard form. So let's go ahead and rewrite these as squares here. So we would have x minus 2 squared over 1 squared equals y plus 1 squared. What's a square root of 9 over 4? That would be 3 over 2 squared. Okay, so let's now determine everything that we know here. So we can find the vertex now. That's the h and the k right here. So we're looking at those. So we have our, I'm sorry, not our vertex, our center, which would be 2, negative 1. Okay, we know our A and we know our B. Our A here is 1, our B is 3/2. So which one is our major axis? Which one is bigger, 1 or 3/2? Obviously 3/2. So our major axis is the y-axis. So that's the longer axis. And the length is 2 times that. 2 times the b value. So it would be 3/2 times 2, which equals 3. And our minor axis length, let's just get that one down too, would be 1 times 2, 2. So let's go ahead and graph this now. So we have all of this information right here. Let's go ahead and graph it. So again, ellipse is going to look a little bit like an oval. We're going to start with our center, which is at positive 2 and negative 1. Our major axis is the y-axis. And the major axis is going to be a total of 3, so it's 3/2 in each direction. And then our minor axis is a total length of 2, or 1 in each direction. So our ellipse looks like that. Again, so you're using the center, you gotta find the center of it, and then you know that the major axis would be the longer one, would be the y-axis. Here we knew that if you want to, again, you can use this. You know that the major axis is 3/2, has 3/2 for b. So we can go up 3/2 and then down 3/2. Here, the minor axis, the a value is 1. So we go to the right one and we go to the left one. And that is what it's going to look like. If you need the other piece of information you may need to use later down the road is to find the foci. Again, the foci here would be c squared. That's the foci, c, which is c. And it equals the bigger number squared minus the smaller number squared. So it'll be 3/2 squared minus 1 squared, which would be 9/4 minus 1, which would be 5/4. So C would be the square root of 5 over 2, plus or minus. So the foci here, if we're looking at the original equation then, so we had C equals plus or minus a square root of 5 over 2. The foci, again, is always along the major axis. So it would be plus or minus the square root of 5 over 2 from the center. That's how we find it. So the foci would probably be about right here and about right there.